for tonight.
Yeah. It's just the test outline that I've been working on with you.
Yeah, that's fine. Just we'll pick up from where we left off.
Okay, so this one is y equals 1/2 x squared plus 4x minus 10.
And the question is to solve?
We have to find the focal point graph f of x, I think, equals 1/41a1. And the y directive, or derivative, I don't know.
I think you mean the Directrix.
Yeah, that's what I meant, sorry.
Okay.
Okay, so the focal point.
We're now talking about quadratics that are more than just quadratics. They're parabolas that have focus and directrix. And we've never really talked about that before. Okay, so the question is how do you find the focus and the directrix?
Well, the focus is the center point of the parabola, correct?
Well, not really.
Or is it just above the center?
Describe it, but it has a very specific mathematical definition. The focus is always inside the parabola, and let's say we have a directrix right there. Well, the definition of a parabola is that every point that is on the parabola is the same distance from the focus as it is to the perpendicular distance to the directrix. No matter where the point is, right there, that distance is the same as that distance.
Okay.
If I'm way up here, that distance is the same as that distance. So, first of all, that's the first difference about parabolas when you start learning about them as conic sections, is they have this different definition. They're not just quadratics, they are a collection of all points that are equidistant from a focus and a directrix. So the question is how we find this, that's called the focal length, the distance from that to the vertex. We're familiar with the vertex. The distance from the vertex to the focus is called the focal length.
So the focus, is that where it ends up hitting the directrix, or is it the
that is just a point inside the parabola.
Okay.
There happens to be a very important reflective property of parabolas. If you take a parabola and turn it into a dish, then every ray that comes in directly will bounce to the focus. Even if it comes in way up there, it reflects to the focus. Even if it comes in way down here, it reflects perfectly to the focus. So if you go outside and you look at people's houses that have a direct TV dish on the top, you'll notice that it's in the shape of a parabola and that it has this receiver some distance away from the vertex. Well, guess what that distance is? It's the focus. Because all of the signals that come off the satellite go into the receiver dish and are reflected to the focus. Okay. So
the focus is where all of the
flashlights are made. If you're designing a flashlight, you build it in the shape of a parabola, you put the light bulb there, and then all the light that comes off of it goes directly out in that direction so that it focuses the rays. So the parabola is a terrific geometric shape because of this reflective property. All of our telescopes, all of our flashlights, all of our direct TV dishes, they're all in the shape of a parabola.
Okay,
now,
I got that.
How do we figure out where the focus is on this parabola? The formula for figuring out the focus, I'm going to write it down here at the bottom because I got to scroll. 4p times the variable that is not being squared minus k is equal to x minus h, the variable that is being squared, with the h and k once again being the coordinates of the vertex. So if I can take this equation and put it into this format, then not only will I know where the vertex is, I will know where the focus is, and I will know where the directrix is, because the directrix is the same distance from the vertex as the focus is.
Okay.
So I somehow have to get it into that formula.
The top one. So the original formula has to be rearranged into that?
Yeah, well, if I can get this into that, then I'll know where the vertex is and I'll know where the focus is. And they said they wanted the focus, and I'll know where the directrix is. So I'll know the focus, I'll know the directrix, I'll know the vertex, I'll know how to graph it, I'll know everything there is to know about it. So I've got to get it into this format. And let me just rewrite it over here so that I can scroll down. All right. So notice the formula on the left is not vertex format. Vertex format is y equals a times x minus h squared plus k. So the very first thing I need to do is move that 10 to the other side. So I have y plus 10 equals 1/2 x squared plus 4x. Same thing, right? Haven't changed anything?
Yeah.
Okay. Now I got to turn this into this format. So I'm going to have to complete the square. But before I can complete the square, I got to get rid of that 1/2. So how about I multiply everything by 2?
Okay.
The entire equation, left and right, by 2. Don't want to distribute it. Remember what my goal is here. My goal is to make it look like this format. If I can make it look like that format, I'm going to have the answer to all your questions. And I'm getting closer.
Okay. So we're going to do something with the square next?
I do need to go ahead and distribute that. You'll see why in a moment. Yeah, I need to complete the square on that. Okay, let's put parentheses around it. How do I complete the square? By adding what? You're always adding, never subtracting. You're always adding.
You adding... What would you add? I think I have it, but I'm not sure.
1/2 of 8 squared.
1/2 of a squared?
1/2 of 8. The coefficient of the next term. You take 1/2 of that and you square it.
Okay, so 16.
Now, because I just added 16 on the right side, I got to add 16 to the left. So, in order to balance it out. In other words, whenever I'm completing the square, I'm always never changing the equation. Now, I can factor out a 2 from the left, leaving that. And because I got this by completing the square means I can write it like this. That's the whole reason you complete the square. There's lots of times when you want to complete the square. It's not just when you're dealing with parabolas. Most any conic section, you need to complete the square. And the whole reason for completing the square is so you can take a quadratic and represent it as a binomial term squared, which is exactly what that is. Okay? Now, remember my definition. This is the format for a parabola when you're talking about conic sections. In other words, if I can put it in this exact format, I'll know where the vertex is, and I'll know what P is, and I'll know what the directrix is.
Okay, I'm a little lost on how we got from 2y plus 36 equals x squared to the next part, like the equation below that one. Do you understand me, or did I mispronounce that?
I might have made a mistake here. Let me check my math. So I have y plus 10 equals 1/2 x squared plus 4x. I multiply everything by 2. I get this next line. I distribute. I get 2y plus 20 equals x squared plus 8x plus 16. Then I got to add 16 over here. Should turn it into 36. When I factor out the 8, I'm left with that. My apologies.
So it's 18?
Uh-huh.
Is it because you divide by 2 on both sides?
No, it's because I didn't do my multiplication right. In other words, when I had 2y plus 20 and I had to add 16, that became 2y plus 36.
2y plus 36?
Yeah, in other words, I needed to add those two numbers. I don't know how I got 8. But I needed to add 20 and 36. And then I factor out a 2, and I'm left with y plus 18. Okay, now notice that is in perfect parabola format.
Okay.
Tell me what h and k are.
Our h and k
What's h?
Is h4
minus 4.
Minus 4. Oh, okay, I got it.
Minus a minus 4 in order to end up being x plus 4. So h has to be minus 4. What's k?
And k is negative 18.
Correct. Now what's p?
Is that 2?
Well, 2 times 4 would be 8, so it's not 2.
2 times, so is it 8?
Here's the deal. That 4p equals 2. So solve that equation.
So this is 4 times 2?
Solve that equation.
Okay.
Every level of math from algebra up is solving equations. If you don't know how to solve that equation, we need to work on that. What is
Well, yeah, it's you plug in the p is 2, right? So then
you solve this for p. How do you solve that for p? This
I think I'm misunderstanding you. Oh, that right there?
That right there.
Okay.
What's p equal to?
Say what?
What is p equal to?
2.
No.
4?
It isn't.
No.
If p were 2, I would have 8 equals 2.
Okay.
So how do you solve for p?
I think I'm misunderstanding this in a weird way.
All right. Right here is our equation.
Yeah.
To solve that for p, I want to divide both sides by 4.
Okay.
So p equals 2/4 or 1/2.
I thought you were plugging in 2 for p.
Not plugging in anything. I just wanted you to solve 4p equals 2.
Okay, that's where I was getting lost.
Yeah. So now we know what p is. We know what P is, we know what H is, we know what K is. Heck, we know how to graph this thing.
Okay.
That's all you need to graph it. In other words, I know that its vertex is at -4, -18. We'll call it right there, -4, -18. That it opens up, and that P is 1/2, meaning P is up 1/2 from -18. So that's where the focus is, and that focus is at -4, -17.5.
Okay.
Because P was 1/2.
All right, I think I got that.
Which means P is located 1/2 unit above the vertex. Additionally, it tells us what the directrix is. The directrix is always a line that's perpendicular to the line of symmetry for the parabola. The line of symmetry is the line that goes straight down the middle, like that.
Yeah.
Okay, so the directrix is always perpendicular to that, and the same distance from the vertex as the focus was. So if that is 1/2, then this is 1/2. Now I know my focus or my vertex is right there. What's the equation of the directrix if it's exactly 1/2 unit below that?
It would be -1/2, right? Because isn't it just the
It's the equation of a line, first of all. When you're talking about the directrix, that dotted line, we need the equation of a line, not a point.
So it'd be y equals.
Horizontal lines are y equals something. Y equals some number is a horizontal line.
So would it be y equals -12? Or not -12, -1/2, I'm sorry.
The vertex is at -18. And we know we're 1/2 unit below that.
Yeah.
So what is y equal to?
So if we're 1/2 unit below it,
and
we're 1/2 below 18, you said -18? So is it just 17.5? -17.5?
How about -18.5? When I go 1/2 unit below -18, I go down to -18.5.
That's true. That makes sense.
So that's the directrix. Remember that your equation for a directrix is always a straight line. It's always the equation of a line, whereas the focus is just a point. The focus in this case is -4, -17.5. It's 1/2 unit above the vertex.
Okay.
So now this analysis of parabolas is really completely different than everything you've ever learned about a parabola, including the general format. In other words, let's examine this for a moment, because it's worth it to look at this. Vertex format of a parabola used to be this. Still is that. Just a different format. Okay?
Okay.
That's a normal quadratic vertex format. Quadratic vertex format. And the reason it's called vertex format is because we know the vertex. H and K are the vertex. Well, when you get to conic sections, which is what you're talking about now, conic sections parabola, the format is this. Excuse me. Now, these may look drastically different, but they really aren't. If you make A equal to 1 over 4p, you wouldn't need to use a different format. Notice that A is 1 over 4p. First thing I'm going to do is subtract k from both sides and then multiply both sides by 4p. And I get this. The advantage of the lower format is that you can figure out where the focus is immediately. You don't have to do this down here. Now, not every school teaches this format, the one that I just double check marked. Some leave it in Vertex format and just let you know that P equals 1 over 4A, which is the same as A equals 1 over 4P. But if you want to solve for the focus, just use that formula. You don't necessarily need to convert it to that format.
Okay.
But I do whatever your school is doing. So if you've seen this format, that's the one they use.
Okay, yeah, I have seen that.
Okay, well then that's the one we want to use.
Okay.
Forget that. Don't need that.
Alrighty.
What you need to do is put all parabolas into that format. Now, notice one thing. The 4p is in front of the variable that is not being squared. The variable being squared is the x variable. The y variable is not. And there is another type parabola. There's this type parabola. Notice the difference. This is an x equal y squared parabola. What we've dealt with for 3 years is a y equal x squared parabola. Well, y equal x squareds are either this or that. They're up and down. When you have x equal y squared, they're sideways. It's either that or that.
Mm-hmm.
So that's the first really big distinction you need to make. Is you need to distinguish between when you have an x equal y squared or a y equal x squared. And the easiest way, I think, for students to do that is to just go back to what you've known for years. The only quadratics you've ever known are quadratics that look like that, correct? Or maybe upside down. You have never talked about sideways parabolas. So if you remember that as being y equal x squared, you'll be fine. The variable that's not being squared is y. The variable that's being squared is x. That is an up and down parabola. If I have this situation over here, the x variable is not being squared, but the y is. That's this kind of parabola. And you're going to get both. In other words, the reason you've never seen that kind of parabola before is because that's not a function. And the way they teach this stuff is they start out with functions. This is called a relation. It's not a function because it doesn't pass the vertical line test. If I draw a vertical line through that horizontal parabola, it crosses two values of y. That makes it not a function. Doesn't mean we can't use it and learn from it. There's a lot of parabolas that are sideways parabolas. So there's still a valuable use to a sideways parabola. But just know that now that you're into conic sections, and the only reason I know that is because you ask about focus and directrix. And those are two words that were never used when we were looking at quadratics parabolas for the very first time back in Algebra 1 and Algebra 2. You never heard the word focus or directrix. But now that you're in Algebra 3, yeah, you're studying conic sections. And parabola is a conic section. It not only has a focus and a directrix, but it has this magical reflective property. So there's all kinds of things about parabolas that you didn't learn when you studied quadratics, but you're learning now. Okay? And that's the most important thing you can learn is the general format. And as we sign off, let me just give you two general formats, and you tell me which one is a horizontal and which one is a vertical.
I think I kind of remember this, yeah.
Hold on. I'm not done.
Well, I know, but...
Which one? You know that vertical ones are the ones that are most like what you've studied up until now. Which is that?
Okay. Is that the second one?
Uh-uh.
No? I thought it was the y.
It's y equal x squared. That's what you've studied up until now.
Yeah, I saw the y in the first
that
place.
That one has a y in it and an x squared in it.
Okay, that makes sense.
That is the vertical one.
Okay.
This one down here in the rectangle does not. It has an x and a y squared. Notice the difference.
I get that now.
That's the horizontal one. This one up here
vertical
is either this way or this way, depending on the sign. But this one down here is either this way or this way, depending on the sign. The key difference is this is an x equal y squared. The top one is a y equal x squared. You've got to be able to remember how to distinguish between one and the other.
Okay, I think I can remember that now.
All right. It's 8 o'clock. It's a good time to stop.
Alrighty. Thank you. I appreciate it.
Hold on a second. Let's see. Oh. That was just a half an hour. We started at 7:30, right?
Yeah.
If you want to go longer, I didn't realize. I was thinking you started at 7.
Oh, no, I'm honestly kind of tired. I still need to get home. I'm at these other people's house still, so I'm probably just going to go for tonight, honestly. I think it's a good stopping point.
Sounds good. We'll keep it.
I'll talk to you.
I'll talk to you next time.
Okay, see you.
Bye.